In this video, I just want to help you get started on completing the ball bounce activity, which you do need to submit to the Dropbox for marks. So on the first page, we have a graph that shows the height of the ball over time. Now, this is not the path of the ball. This is not the actual ball bouncing. This shows the height that as time goes by, the ball drops, bounces, its height increases to the maximum height, and then it bounces again. So make sure that you really realize that the units along this horizontal axis are time in seconds, and then the unit on the vertical axis is height. So we're going to look at average rate of change over some intervals. So they have given the intervals A, B, B, C, and so on, and we have the points on our graph that match. So coordinates of the endpoints really means to do your best and look at the graph and estimate where the points are. So for the first interval, AB, I'm going to look at my graph and estimate that A is at 0, and that's 220, that's 200, so 212 is about right. Don't get too obsessed with trying to get exact measurements here as long as it makes sense. B, if I look at here, that's 0.2, it's a little before that, 0.1 is there, so I'm going to guess it at 0.13. And then the height, if I look, is about 55. Might be a little bit higher, but 55 is close enough. So then the average rate of change is the slope of the line, or rise over run. But in this case, our rise is height. So I can think about it as delta H, or change in height, over delta T, because time represents our run. So I'm going to subtract. Doesn't matter what order as long as you're consistent. So I'm going to do 212, subtract 55, divide it by 0, subtract 0.13. And I'm just going to do that in my calculator. I don't need to see a lot of work. And so then we get our rate of change. So it's negative 1,207.7. And the units for this, our height is in centimeters and our time is in seconds. So if we wanted to think about this as having units, it's that many centimeters per second. So now hopefully you can complete the rest of the chart using the endpoints. On the second page, we're going to start to use some of the information from the first page and put it together. So the first thing, it wants you to sketch a curve of best fit. So you're just going to go and connect the dots as best as you can. Try and hit the dots to get the actual curve. Now, if we look at number 1, it says on the interval AB, the average rate of changes. That's where we're going to go back to our work from the first page and pull our answer off of that. So negative 1,207.7. Now, I can draw the secant AB by connecting the points AB. And I'm going to leave my ruler there on purpose because it says the point whose tangent matches this rate of change is, and this is where we're going to do our best to estimate it, but I'm going to keep my ruler on that same slope because this slope represents the negative 1,207.7, and I'm going to slide it along until I just skim at one point. And hopefully if you're doing this on your own sheet, you'll see that there is a point there that if I keep my ruler relatively the same, that is the actual point. So I'm going to call that point 1. It didn't have a letter on it, but it was a dot on the original graph. I'm kind of muddying it up a little bit with my marker, but it was there. So now if I estimate the coordinates of that point, it's at 0.07 and 147. And again, I just looked at that point and used my scale to try and come up with the height of it. So you're going to repeat that process both on the front page to find all of your slopes and rates of change, and then on this page, do the information. If you have more questions with this, completing it, please feel free to email me.